This first question asks you how many stereoisomers riboflavin will have. Here we need to do two things. First, we need to remember that the number of stereoisomers that a molecule has is defined as 2 to the number of stereocenters in that molecule. Then we need to figure out how many chiral carbons the molecule has. So we'll look for the carbons that are bound to 4 different groups, and we have 3 indicated here with red circles. So the number of stereoisomers of riboflavin will be 2 to the 3rd, or 8 stereoisomers. In this question, you're asked to determine the relationship between each pair of structures shown. In the first case, these are enantiomers. It's a chiral molecule with one stereocenter, and the two drawings are mirror images of one another. In the second case, we're looking at 2 different depictions of the same meso compound. The compound on the right is a mirror image of the compound on the left. It's a meso compound that has 2 chiral carbons and a plane of symmetry. The 2 structures here are superimposable with one another, so they're identical. In the last case, the 2 structures are diastereomers. They're not mirror images, and they have some, but not all, of the stereocenters inverted. Here we're given a Fisher projection and asked to assign the stereochemistry. For this example, I recommend converting the Fisher projection to a wedged dash drawing that you're more used to looking at and thinking about. To do that, we need to remember that the horizontal positions are coming forward and the vertical positions are pointing backward. Then we can draw this structure. It's not a correct depiction of stereochemistry, but it helps us convert the Fisher projection into a line drawing. So from this drawing, I can imagine looking at the molecule from the right. That puts the hydrogen pointing back, the OH group pointing toward me, and the aldehyde, the CHO group, will be to the right, and the rest of the chain will be to the left. That will look like this structure. Now I can assign R and S the way I'm used to. I assign priorities to each of the 4 groups. The hydrogen, the lowest priority group, is pointing back here, so I can just focus on the other 3 groups. The alcohol is the highest priority, then the aldehyde, and the rest of the chain is the 3rd priority. I draw a curved arrow from 1 to 2 to 3 and find that this chiral center has R stereochemistry.